Hi, my name is Stewart Lynch. If you're familiar with SwiftUI, you'll have heard of property wrappers. In SwiftUI, we have @state, @binding, @stateObject, and many more property wrappers when dealing with representation and state regeneration of our views. I have a complete video on these SwiftUI property wrappers, but in this video, we're going to be looking at how you can create your own custom property wrappers and learn about two special properties, the wrappedValue and the projectedValue, and how you might want to use them in both UIKit and SwiftUI implementations. If this is something you want to learn, then keep watching. I've created a starter multi-page playground project that you can download from the link in the description below. There are 2 pages besides the introduction, with some sample code in each. I'm taking an idea from Ray Wenderlich and including with each page a helper file that will keep each of the examples contained within a closure. And this means that we'll be able to recreate the same struct for multiple examples, as the code will be isolated within a closure and will not conflict with other examples, even if we use the same struct names. It also has the benefit of keeping our print statements separated. You really don't have to worry about this. All we have to do is make sure that any code that we want to isolate within an example, we keep within the closure. So let's get started. On the first page, we'll be looking at the use case for property wrappers. A property wrapper is the Swift language feature that allows us to define a custom type that implements behavior from get and set methods and reuse it everywhere. Let me show you what I mean by that. Let's say, for example, that you have a struct called name and 2 properties, first name and last name, both strings. We want to ensure that whenever a new instance of name is created, both the first and last names are always capitalized. And if we do this right now, let's enter a new instance and print out the first name and last name. As expected, we get exactly what we typed, the first and last names printed out. So how do we go about ensuring that when they are printed, the first and last names are always in caps? And there are a couple of ways to do this, and one would be to add 2 computed properties that would return the uppercase versions of these 2 variables. Well, that's not the approach I want to take. Instead, before we look at property wrappers, let's take a look at using a property observer on each property so that when we set a new value, we apply the uppercase function to it. So, for first name, we'll specify didSet with first name equal firstname.uppercased. And we'll do exactly the same for the last name. DidSet last name equals lastname.uppercased. Running this now shows a problem, and that is that it doesn't capitalize on initialization. The member-wise initializer of our struct doesn't trigger the didSet function. If we change one of the properties after the initialization, like our first name, and run it again, we see that that updated property does get capitalized as expected. So to solve the problem on initialization, we'll need to add our own initializer where we'll do the same didSet transformation when the instance is initialized. This time it works. Of course, if this were a class, we would have to have provided the initializer anyway. Now that's a lot of code to write, and what if you had lots of properties that you wanted to apply that transformation to? Well, this is where property wrappers become very helpful. A property wrapper has 2 minimum requirements. You create a class, a struct, or an enum that is decorated with the @propertyWrapper annotation. So let's call ours all caps. Now, every property wrapper requires a property called wrappedValue that is of the same type as the property that we want to decorate. So in our case, that would be a string. With that created, we create a property observer on our wrappedValue that will perform the same transformation that you require, which in our case is to uppercase the string. Now, if you're performing a transformation on that value, then you'll want to also ensure that there's an initializer for the wrap value that gets that same transformation applied to it. Well, now that we have that created, we can decorate any of the properties that we want to uppercase with the @all caps property wrapper annotation that we just created. Well, this is the same struct that we had in our first example, so let's try that same instance for creation and printing. Executing the playground now, the problem's solved. Well, now that we know that this works, if this were a full Xcode project and not a playground, we could have moved this property wrapper struct here into its own file for use in any class or struct that we have in our project. Let's take a look at a second example. And this is a pretty common use case. In your app, you have a model with a number of string properties like this one, and you want to ensure that when an instance of the struct is created, there are no leading or trailing spaces. Right now, if I create an instance of this struct like this with some leading and trailing spaces around our first and last name properties, and then try and print that out, we'll see that our output maintains those spaces. I'd like to have those spaces trimmed, and this is another great use case for property wrappers. So let's do that now. Again, we'll start with @propertyWrapper for our struct, and I'll call it trimmed, and I'll create the required wrappedValue property, and the type will be a string. So instead of using the didSet property observer, I'm going to use a getter and a setter on our wrappedValue. This will require the introduction of a private string property that I can manipulate within the struct, and then let me create our set and get blocks. Now when we set our wrappedValue, it generates a new value called newValue, and we can assign that new value to our private text property. And then for the getter, instead of returning the wrappedValue, we'll return the text, but apply the strings trimming characters function with the whitespace and new lines character set. We'll also need an initializer here for our wrappedValue, and we'll assign the initial value of wrappedValue to our text property. Let me decorate my string properties now with the trimmed property wrapper. And when I execute the block, the strings are trimmed. Let's look at another example. This time with the struct exam that has two properties, a student as a string and a score as an integer. Let's create an instance of this struct for a physics exam and give it the name Stewart with a score of 120. And then if we want to print out the score, we can do that too. Now the problem that I have here is that I want to cap the exam score at 100 and also make sure that there are no negative scores, i.e. none below 0. Well, we can use a property wrapper for that. So let's call this property wrapper inRange and add our wrappedValue, which this time is an int. I'm going to take the same approach as we did in the last example. I'll create a private property called score and use a getter and a setter on the wrappedValue. And I'll also need an initializer for that wrappedValue. Like the previous example, when we set our wrappedValue, we set the score with that new value. And when we get our value, we first apply the transformation on the score. And what we'll do is we'll return the max value of 0 and the minimum of our score and 100. Essentially what this does is restrict any values to be between 0 and 100. And of course, in the initializer, we simply initialize our score with the wrap value. So now we can decorate our score property with the in-range property wrapper. And running this, we now see our score is capped at 100. If we change the score to -5, the minimum value of 0 is provided instead. Now this is a pretty restrictive property wrapper. I'm always restricted to exams with scores between 0 and 100. What if I have other exams and I want a different range? In order to do that, we have to add some properties to our property wrapper. So let me copy and paste what we have now into the next example and make some modifications. Let me add 2 more private properties to our property wrapper. One an int for minimum score and another for max score. Now I can replace my hard-coded values in the getter. This also means I have to add 2 more arguments to the initializer. And this creates an error, and it shows up when we are creating our instance. The issue, however, arises from the property wrapper, however. It is a struct with 2 new properties, and we need to have initial values. This shows that we also need an initial value for our wrap value too. Well, we can set our minimum score to say 10 and the maximum to 80, but what do we do about the wrap value? Well, the wrap value is a computed property, and it will change to whatever we set our score to on the initialization. So we can basically assign any integer that we want, and when we create an instance of the struct, it will change. This still gives us an error, however. But remember that the new wrap value is actually going to be assigned the value of our score. So we can leave it out of the argument entirely and set an initial value here for our score. But we could use any int value because it will be overridden when you create a new instance of the exam. For example, let's set our physics score back to 120. And if we run this same playground now, we'll see that the score is maximized at 80. If we change the score to 5 and execute again, it's set at 10, our minimum. Now, one last thing before I move on to projected values. This property wrapper is restricted to integers. If we want to use it for all numeric types, we can use generics. So one more time, let's copy the entire solution from the previous example and paste it into the next slot. All we have to do is add a generic t assignment to our property wrapper and also specify that it must be numeric. Then we can replace all of our int types with t. Now this almost works, but it displays one more error in that our type must also be comparable. So we need to add that to our type definition. This still works with the existing code, but we can also use double values because they're numeric and comparable. So let's change our minimum score to be 0.5 and our maximum to be 1.0. And then of course we'll have to remove the int designation for our variable, and it can be inferred from our range that it will be a double. So we can just leave any type designation out, and we'll just set our default value as 0. Now let's adjust our physics score to be a value of 1.5. And when we execute the app, we see it's restricted to 1. If we reduce the score to 0.2 and execute the playground again, we're presented with a minimum of 0.5. The only values that will work are those between 0.5 and 1 inclusively. Property wrappers can also have a projected value, And this means that we can create another representation of the property, and it can be a different type entirely. For example, let's assume that you live in the US and you always format your dates as month, day, and year. And you want to be able to decorate any date with a property wrapper so that it will always give you that formatted date when you request it. Now, what I would normally do is create an instance of our struct, and I'll give the date for the birth date, and I'm just going to use today as the date. Next, I would create a date formatter instance, and then set the date format of that instance to my required format, like this. Next, I'd use the string from date function on date format to print out the date. This gives me the desired result, but what if I had lots of dates? I want to keep this code out of my views and make it reusable. So let's do this using a property wrapper with a projected value. So as before, we'll create a property wrapper, and we'll decorate it with the property wrapper designation, and we'll call it US date, and include the required wrap value, which will be a date this time. Now, we're not going to manipulate that wrap value, which is assigned to our property, but rather return a string that will be the US date formatted version. So for this, we can create what is known as a projected value, and it can be a computed property. Now I can use that same date format string from our previous example, and then return a string value using the wrap value of our property wrapper, which is the underlying date value. Now, no initializer is required for this example. Now I can decorate our birth date property in our person struct with that property wrapper. Now, in order to access that projected value of a property wrapper, we'll use the $ prefix on its property. So if I want to print out the string version of the birthday, I'll just print me.$birthdate. Of course, we'll always have access to the original date value. We'll just leave the $sign off. Now let's improve on this by making it a bit more generic. First, let's copy the code from that previous example, paste it into the next part, and I'll change the property wrapper to formatted date, and I'll change the decoration on our struct as well. Next, I'll add a new string property for our property wrapper called format and replace the string with that variable. Adding a new property means that we'll have to create an initializer, and we'll also have to include the wrap value as well here. Now this means we'll also have to add a formatted argument to our formatted date. So let's specify EEE, MMM space D, YYY. And as we saw with wrap value, we can set an additional date for the wrap value. And of course, when the instance of person is created, we can override that date with the real one. Running this now, we get our desired result for our formatted birth date. Now, if we want that format to be the default and allow for it to be optional to change the format, we can remove that format string directly into our property wrapper's initializer. And with it removed from the property wrapper, we get the same result. But this does give us the option to add in a formatter if we choose. So how about YYY-MM-DD? Running once more, we get our desired result. For our final example, I'd like to consider this struct that can be used as a review for a restaurant. I want to allow for a review of the general ambiance and another for the food delivered. So I'll create an instance of this for one of my favorite restaurants, Earl's, and give it a 5 rating for ambiance and 4 for food. Now, I'd like to create a property wrapper that I could use to assign to our 2 integer properties a projected value that would show a custom emoji repeated equal to the number of times that matches our rating value. For example, 5 stars for ambience and 4 emojis of some other type for the food rating. So let's create a property wrapper that will do that for us. We'll start as always by decorating our struct with @propertyWrapper, and I'll call my struct rating and add the required wrap value, which is an int. The projected value is going to be a string, but I also want to be able to provide an emoji for that rating image. So let's create both of those properties. For the projected value, we'll just return the string, repeating the emoji string for a count of the wrap value. Also, as before, this will require an initializer for the wrap value and the emoji string. So let's default it to the star. Let me decorate the 2 properties in our struct using the default star as our ambiance emoji, so no need to provide an argument to the property wrapper. But for our second rating, let's use an emoji for food. How about this plate? Now we get that error saying we need an initial wrap value. So as before, we'll just set it value to some random integer, knowing both will change when our instance is created. Now we can print using the $ prefix to represent the projected value. And there you have it. All you'll need to do if you want to use these property wrappers in your own projects is to create a new file in your projects and copy and paste these structs into that file. I hope that you see the power behind property wrappers. Notice that apart from the introduction, there's been no mention of SwiftUI. Property wrappers are pure Swift and can be used to decorate properties in your classes and structs in both UIKit and SwiftUI projects. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.